Hey, this is Mr. V with the first of a couple videos on solving percent problems. First thing to know about percent problems is that they all follow the same structure. They all look the same. It all comes down to something like this. P percent of, right, where P is just some number, P percent of some total amount is some other number. A simple example of that would be 50% of 12 is 6. If we pare that down, abbreviate it a little bit, it looks like that. Some percentage of is multiplication in mathematics. Every time you hear of, that's multiply. Some percent of some total amount is, that's an equal sign, some number. This is called the percent equation, and every single percent problem you come across will be solved using this basic equation. They all have that same structure. Now, there are three types of problems that you'll come across. They look like this. You have the percent, you have the total, you're looking for the number. That's the first type. Second type looks like this. You have the total and the number, but you don't know the percentage. And the third type looks like this, where you have the percentage and the number, but you don't know the total. I won't give examples of these because I'll cover those in the next video, but I will go on now to some examples of this first situation. Here we go. So this is the structure we're working with. We have a percent, we have a total, we're looking for the number, and here's an example for this kind of problem. 24% of 75 is what? Right? We're looking for the answer to this problem. This is the most traditional of the percent problems, the one that most people have the easiest time with. And there are two ways to approach it. I can convert 24% to 24 over 100, 24%, 24 hundredths, like that, using fractions to solve this problem. Or I can solve the problem using decimals. I'm just going to split this down the middle here, keep things separate. And I can also do it like this. It's a matter of preference. Some people are more comfortable working with fractions, others prefer decimals. You should be able to do both. And there are times when fractions are going to work out just great, and other times when decimals are just going to be easier. Fractions work out really well in an example such as this one, where you have a way to simplify things. Here, 75 and 100 have a greatest common factor of 25. If I take that out, if I factor out the 25, 100 is the same as 4 times 25, and 75 is 3 times 25. 24 has a 4 in it. I can factor 24 and 4 times, sorry, I'm not being consistent with my multiplication signs. 4 times 6, 25 divided by 25 is 1. 4 divided by 4 is 1, and I'm left with 6 times 3, which is 18. 24% of 75 is 18. If I'm using decimals, I count my decimal places. I'm just going to show the traditional method now. There are many ways to multiply with decimals, but this is the most straightforward right now. Count my decimal places. I have 2. I multiply as if they were not there. And 4 times 75 is 300. And 20 times 75 is, 2 times 75 is 150 with a 0, so 1500. 1800 is my total, and I had 2 decimal places, put them back in because I'm really multiplying by 0.24, and my answer is 18. At this time, I'd like you to try a problem on your own. Please give this one a shot. Do 35% of 80. Give this a try. It would be great if you could do it both ways, using fractions and decimals. And pause the video, give that a shot. When you're ready, come on back and we'll work through it. All right, 35% of 80, I'll do it both ways. 35 percent of 80 should work out nicely. 180 have a greatest common factor of 20, so I can factor out 20. 100 is 5 times 20. 80 is 4 times 20. 35 has a 5 in it. It's 5 times 7. 20 divided by 20 is 1. I'm finding my equivalent forms of 1. 5 divided by 5 is 1. And what's left is 4 times 7, which is 28. 35% of 80 is 28. Using the decimal approach, well, 35% of 80 is 0.35 times 80. And I can count my decimals. 1, 2, multiply as if they were not there. 80 times 35. 5 times 80 is 400. 3 times 80 is 240 with a 0 because it's 30. 2400. It's 2800. I was really multiplying by 0.35. I have 2 decimals, so I place 2 decimals in my answer. And it's 28 once again. We'll do one more problem and then wrap this up. All right. For this one, we're going to use a percentage and a number that are not so friendly. 27% of 79. I want to know what that makes. Well, using the fraction approach, 27% of 79. I glance at that, take a look. There's nothing in common. There's nothing that simplifies here. No common factors between 127 or 179. So I'm just going to have to end up multiplying 27 times 79 and then dividing by 100. And go off to the side here. 79 times 27. 7 times 9 is 63. 7 times 7 is 49, and 6 is 55. And 2 times 79 is 158. But it's not a 2, it's a 20, so I need to leave a 0 here. 1580, I get 3. That's 13, and 1 is 1, and 1 is 2133. So this is 2,133 divided by 100. Dividing by 100 moves the decimal over twice. I get 21.33. If I did this using decimal, it would look like this. Let me just split this here quick. And I would have done 27 hundredths written as a decimal times 79. I would multiply 79 times 27 as if it was a regular number, a whole number. I count my decimal places, 1, 2. 79 times 27, well, I know what that is. I did it right here, so I'm not going to waste time here. That's 2,133. I had 2 decimals here in my factors, so that means there are 2 decimals in my answer. Put them back in, I get 21.33. Same answer. 21 and 33 hundredths. Okay. Please give this problem a try, and then we'll wrap it up. Try 13% of 37. Pause the video, give that a shot. Try to do it both ways. You'll find that it's really almost the same thing. Come back when you're ready. I'll work through it, and we'll wrap it up. Okay. 13% of 37. Again, it's one of those where there's nothing in common between 13 and 100 or 37 and 100. So I just go ahead and multiply 13 times 37, and then I'll divide by 100 when I'm done. Off to the side, 37 times 13. 3 times 37, that's 90, and 21, that's 111. And 10 times 37 is 370. Gives me 481. I get 481 over 100. Dividing by 100 moves the decimal over to the left twice. 4.81. 13% of 37 is 4.81. Using decimals, that's 0.13, 13 hundredths. times 37. Count my decimals. 1, 2. Multiply as if they did not exist, as if I was multiplying whole numbers. I know what this is. I won't waste my time. It's 481. I was multiplying with 2 decimals. This is really 0.13, so put them back into your answer, 4.81. And there you go. Voila. That's how you do it.